Today we are doing lesson 3-4, finding the exponent. Your goal is that you will be able to find the exponent of a sequence using logarithms. And up until this point, basically, we have taken the formulas for a geometric sequence and series, and we have found the sum, or we have found the first term, or we have found the common ratio. But what we have yet to do is to actually find the exponent, right? We've always known what term we were looking for, or something, or anything like that. But this lesson is like a lesson that comes before it. This is what's going to help you actually find that exponent, that variable that's in the exponent. Okay, and it's a process called logarithms. Now the thing is that a logarithm basically answers this question: how many of one number do we multiply to get another number, aka what is the exponent? So I have right here a very simple example for you, which says solve for x, and we have 2 to the x equals 8. And it's basically asking, okay, so what's the value of x? How many times do we have to multiply 2 to get 8? Well, as you can see from the answer, 2 times 2 times 2 is 8. So that means we need to multiply 3 2's together to get 8. So how many 2's do we need to multiply? We need to multiply 3 of them. So the logarithm is 3. So x equals 3. Now, this is a very simple example, but this can be found by doing the log of 8 divided by the log of 2. So that is the log of the answer divided by the log of the base. And how you actually figure that out is that you would need to use your calculator. Now, if you're using one of the calculators that we have in class, one of those very basic ones, since from like Algebra 1, you're going to have to actually work backwards. So what you're going to do is you're actually going to type 8, then the log button, which is 2 buttons to the right of the green second button, then the divided by button, and then 2, and then the log button again. And I accidentally wrote 3, so excuse me for that. It's actually 2. So I'm going to make that change. And we should get our answer. And it is 3. Okay, so with those calculators, you got to work backwards. With a normal calculator, more advanced scientific or graphing calculator, you just pretty much type log 8 divided by log 2 and you get your answer. But this is how we go about figuring out the exponent when the variable is in the exponent. So now what we're going to do is we're going to look at some examples. Okay, the first one we have is 11 to the x equals 48. So just like before, it's going to be log of our answer divided by the log of our base. So that's the log of 48 divided by the log of 11. So we're going to type in 48 log divided by 11 log equals. You got to click the equals, otherwise it's just going to still be remaining whatever the log of 11 is. So make sure you click your equals. And then you're going to get your answer, which is 1.61446, and so on and so forth. Now, I'm going to ask that you round to 3 significant figures. Now, with 3 significant figures, you start with your first non-zero number. That first non-zero number is 1. After that, you count forward. So 1 is my first significant figure. 6 is my second significant figure, and then 1 is my third significant figure. So at that point you would stop, but you got to look at the number that follows the third significant figure to see if you're going to round up or if you're going to keep it the same. And when we look at this particular example, we're going to leave it at 1. So our answer is 1.61 rounded to 3 significant figures. That's the value of x. Now the thing is that x, for these types of examples, I'm just trying to get you guys to learn how to work with them. So yes, x is going to be a decimal, maybe be some crazy decimals. All right, but just because it's crazy doesn't mean it isn't wrong. If we look at the next example in a similar format, it's going to be log 31 divided by log 18. So that means we're going to type in 31 log divided by 18 log and click enter. This one is 1.18807 and it keeps on going. So when we round this to three significant figures, we're going to start with our first non-zero number, which is 1, and then we're going to count forward. So that's 1.18, but then the second 8 is going to cause us to round that first 8 up, and that's how we get 1.19. All right, for the next examples, as you can see, these are a little bit different, and that is because we have just more up in the exponent. But we'll still treat it the same way. We're going to do log of our answer divided by the log of our base, and that's going to equal n minus 2. That's going to equal our exponent. So once we type in log 34 divided by log of 7 and get our answer in our calculator, we're going to have to do one more step before we can actually solve for our variable, and that's going to be, to get it by itself, we're going to have to add 2 to both sides. Okay, so in our calculator, we're going to do 34 log divided by 7 log, enter, and then add 2 to that answer to get our final answer for n. And then rounding to three significant figures, n is going to equal 3.81 when you round to three significant figures. Now I want you guys to try the one at the bottom. Hopefully you're doing log 72.1 divided by log of 8, and you're setting it equal to x plus 5. So we're going to type it in, 72 log divided by 8 log equals, and then subtract 5 to get our final answer of x equals negative 2.94 once we round to three significant figures. Now the one in the middle, it's different, but we're still going to set it up the same way. Log 82 divided by log 19. And that's going to equal a negative 3r. So the log of our answer divided by the log of our base. So when we type it into our calculator, it's 82 log divided by 19 log, enter, or equals. And then the final step, we will have to divide that answer by negative 3. And when we do that in our calculator, we're going to get that r equals negative 0.49887. Now when you round this to three significant figures, that's 1, 2, 3. The second 8 is going to cause us to round the first 8 up. So our final answer is going to be a negative 0.499. And that's the value of r. One thing you need to remember with significant figures is that you start with your first non-zero number. So with three significant figures, you start with the first non-zero number. Make sure you write this down so that way you know how to round three significant figures. So for that last example, you don't start with the 0, you start with the 4. Now, these examples are going to be more like the types of problems that we're going to be dealing with geometric sequences, okay? As you can see, we have 4 times 3 to the k minus 9 equals 94. So the first thing we're going to need to do is we're going to need to get our base by itself. So that means is that we're going to have to divide by 4 to start this problem off. So we're going to divide both sides by 4, and we're going to get 3 to the k minus 9 equals 23.5. And now this is just similar to the problems that we were working with before. Okay, so that means we're going to have to take the log of 23.5, and then we're going to divide it by the log of 3. So remember, the log of our answer divided by the log of our base, and that's going to equal k minus 9. So we're going to type that into our calculator, 23.5 log divided by 3 log, and then we're going to have to add 9 to both sides to get our value of k. And as we can see, that k is going to equal 11.87 But when we round to three significant figures, it's going to be 11.9. Now let's look at this last example. We have negative 4 times 7 to the n minus 7 equals negative 74. So we're going to start by dividing both sides by negative 4. So then you're going to have 7 to the n minus 7 equals 19. So log of 19 divided by the log of 7 equals n minus 7. So once we type that in, our final step is going to be to add 7 to our answer, and n equals 8.51 once we round to three significant figures. Now this lesson of 3-4 of finding the exponent, again, is supposed to help us when finding the exponent of a geometric sequence. So how does this apply to sequences and series? Well, let's go back to the 3-5 foldable. And let's look at number 3 on the 3-5 foldable. This one asks you to find the number of terms. You have 1 plus 3 plus 9 plus ... plus 2187. In order for us to figure out what term 2187 is, we're going to have to use the formula of a to the n equals a sub 1 times r to the n minus 1. Let's plug in everything we know. We know our first term, which is 1. And we can figure out our common ratio by dividing our second term by our first term, which is going to be 3. Then we're going to raise it to the n minus 1. Now we're looking for n. That's what we're looking for. So we're going to set it equal to 2187 because that's the last term. That's the term that we're trying to find. And just a reminder, divide your second term by your first term to get your common ratio. That's how we got 3. So we're going to plug in 2187, and we're going to set it equal to what we have. Now this one's set up like the last two problems from the 3-4 examples. So we're going to start by dividing 1 by both sides to get the base by itself. And 2187 divided by 1 is just 2187 equals 3 to the n minus 1. Now we're going to do the log just like before. Log of our answer divided by the log of our base equals n minus 1, our exponent. Now, because we're looking for a term in the sequence, the numbers cannot be negative and they cannot be a decimal. So when you're looking for the value of n, when you're doing this log in your calculator, it should be a whole number. If it's not, you've done something wrong. So 2187 log divided by 3 log equals, and we're going to end up getting 7. So 7 equals n minus 1. So add 1 to actually figure out what term it is, and 2187 is the 8th term. It is the 8th term. So we use the geometric sequence formula of a sub n equals a sub 1 times r to the n minus 1, plug in all the information that we have, and apply logs to actually figure out what the value of n is. Remembering that n cannot be a negative number nor a decimal. So it has to be a whole number and it has to be positive. Now the last example from the 3-5 foldable says 3 plus 1 plus 1/3 plus 1/9 plus ... 1 over 243. So we're going to use the same formula of a sub n equals a sub 1 times r to the n minus 1, and we're going to plug in everything. We're trying to figure out what term 1 over 243 is. So we're going to set that equal to our first term, which is 3, times our common ratio. Remember, you can find this out by doing your second term divided by your first term, and that's going to give you a 1/3. Then that's going to be raised to the n minus 1. So we're going to go into we're going to start by dividing both sides by 3. And the thing is that when you do 1 over 243 divided by 3, you are going to get a decimal. But if you go into your calculator and you use the button that has an A and then a B/C, it's going to allow you to actually do the fraction. And then it's going to give you a fraction. So if you do 1, press that button A, B/C, 243, then the divide button, then the 3 button, it's going to give you an answer of 1 backwards L 729. That backwards L basically serves as the fraction. So this is basically 1 over 729 equals 1/3 n equals, 1 over 729 equals 1/3 to the n minus 1. So now we can go ahead and do our logs. So it's going to be log of 1 over 729 divided by the log of 1/3. So we got to work backwards. 1 over 729 log divided by 1/3 log equals n minus 1. So again, this should be a whole number when you do it, and the whole number should be 6. So 6 equals n minus 1, add 1 to both sides, and n equals 7. This is how you use logs to find the number of terms, how to find the variable when it's in the exponent.